My dear Form 4 students, okay, so today I would like to do another video teaching on mathematics reasoning. So let's study together to do revision for your final exam. Complete each statement below by using the quantifier or sum to make it a true statement. So the answer is some multiples of 5 are even numbers. That will make the statement true. Okay, for number 2, it should be all hexagons have 6 sides. That will make the statement true. For B, you are given 2 statements. Combine the 2 statements above P and Q by using the word or to form a compound statement. So the first statement is P, negative 8 times negative 3 equal to 11. Okay, we'll combine P and Q using or. Okay, another statement is 35 is a multiple of 7. So we will add the word or first. Okay, because we need to form the compound statement by using or. Then we copy the statement Q. 35 is a multiple of 7. This is called compound statement. So now we need to determine whether the compound statement is true or false. If for all statements, either one true, it will be true. Right? So we check 35 is multiple of 7 is true. And the first statement, negative 8 times negative 3 equal to 11 is false. So either one true is true for all statements. Okay, so the statement for compound statement, negative 8 times negative 3 equal to 11 or 35 is a multiple of 7 is true. Okay, how to memorize the table is you look at the P and Q. Okay, for n compound statement A and D, both statement true when you use n, okay, it will be true. The rest will be false. Okay, alright? For n statement, both true, it will be true. The rest will be false. For all statement, if P false, Q false, both false, then the compound statement will be false. It means the rest will be true. Okay, so we just memorize one for each one. For n, both true, it will be true. The rest will be false. That means either one false, it will be false for n. Of course, when both false, it will be false for sure. But for all statements, if both false, then it will be false. That means either one true, it will be true. Of course, if both are true, it will be true for sure. Right? So please memorize the table. Okay, for this one, determine whether each of the following statement is true or false. 47 is a perfect square. It is false because if you square root 47, you won't get an integer. Alright, so when you square root the number, you can't get integer. That means it won't be a perfect square. Number 2, the highest common factor of 18 and 27 is 9. So you need to find the common factor. Okay, so we divide by 9. So 18 can be divided by 9 and 27. So then you will get the 2 and 3. 2 and 3, you don't have any more common factor. So that means this is true. Okay, 9 is the highest common factor of 18 and 27. So that is how you work out the answer. So the highest common factor of 18 and 27 is 9. It is a true statement because there is no common factor of 2 and 3. So the highest common factor of 18 and 27 is 9. Is true statement. Okay, for B, write 2 implications. based on the statement. So you are given the statement using if and only if. Can you see that there are two if there? So you have to split out into two implications. If P union Q equal to P, then Q subset to P. Right? So you have to use the word if, and then for the first implication, and for the second one, you look at the blue one, you have to reverse. If Q subset to P, then P union Q is equal to set P. Okay, let's discuss question number 4. 30 is a multiple of 5 and 7. This is false because 30 cannot be divided by 7. And 5 power 3 is equal to 1 to 5, or 25 divided by 9 equal to 3. So this is true because 5 3 is equal to 1 to 5 is true. Either one true will be true. Both true will be true. So for all statements, we just check either one of them true, it will be true. Alright, so please remember, for all statements, either one true, it will be true. Okay, so even though 25 divided by 9 is false statement, but this is an all statement, so 5 power 3 equal to 1 to 5 is true. Hence, the compound statement, okay, for 5 power 3 equal to 1 to 5, or 25 divided by 9 equal to 3 is true, because one of the statement 5 3 equal to 1 to 5 is true. Alright, so let's see B. All polygons have equal side. Now you need to write a statement to negate the statement above. Either you use a word no or not, and hence determine whether, okay, the negation of the statement is true or false. So, okay, so how to do this? We'll copy the statement, all polygons, and then we split. Have equal side, we leave the space, and then we will fill in do not have equal side. We will fill in do not. Okay, do not have equal side. So all polygons do not have equal side. This is the negation of the statement. So the negations of the statement false, because this is because only regular polygons have equal sides. So if it is irregular, the sides of the polygons are not equal. Okay, so this negation of the statement is a false statement. So example of regular polygons like hexagon or pentagon, okay, they are having the equal size. Next, we will discuss this one. Determine whether the following mathematical sentence by using the symbol in the empty box to form a true statement. So negative 15 is less than negative 8 because negative 15 is smaller than negative 8. So it is a true statement if you write the symbol less than. Negative 15 less than negative 8. Okay, so the right symbol is less than for number 1. So it becomes true if you fill in the less than symbol. Okay, for number 2, you can press your calculator for 1/7 for the decimal value and 1/5 for the decimal value, and you realize that 1/7 is smaller than 1/5. So you want to make a false statement, you have to make the symbol become bigger. So 1 over 7 is bigger than 1 over 5. So it is a false statement if you write the symbol more than. Okay, 1 over 7 more than 1 over 5 is a false statement. For B, given the following arguments, premise 1, if 5x equal to 20, then x equal to 4. Premise 2, x not equal to 4. Conclusion, 5x not equal to 20. So let's study this one. Is the argument valid and sound? So in order to determine the argument valid and sound, you have to follow exactly the form 1 and form 2 and form 3. So if it is followed exactly, we actually say that it is valid. So it seems like if P then Q, not Q, not P. So it follow the form 3. If P then Q, not Q is true, not P, right? So in exam, you are not given the form 1 and form 2 and form 3. So you need to memorize the form so that you can answer whether the argument is actually follow exactly form 1, form 2 or form 3. So from the form of the arguments, so we can see it follow exactly form 3, so the argument is valid. Okay, and then how to determine whether they are sound or not sound? We have to check all the premises and conclusion. If all the premises and conclusion are true, then it is sound. So now we check the premise 1, 5x equal to 20, then x equal to 4, it is true. Then for premise 2 also, x not equal to 4 and conclusion 5x not equal to 20. So it seems like premise 1, premise 2 and conclusion are true. So the argument is say it is sound. So this is a sound argument. For this type of question, write premise 2 to complete the following argument. So you highlight the similar one, or you can say you cancel out the similar one. Then ignore the all, then you just copy PQRST. Okay, PQRST is a regular pentagon. Okay, that is how you complete the premise 2. For B, the following is a statement. Determine the truth value of the statement. Okay, if P then Q. Okay, this is the if then statement. Okay, if P true, Q false, so it will be false. Okay, that means if the first statement 2 plus 3 equal to 5 is true, then 2 times 3 equal to 15, the last statement false, then it will be false. So if you have true, false, the truth of the statement will be false. The rest other than this will be true. Alright? So that means if you're having true, true, it will be true. If true, then true. If false, then true. Okay? If false, then false. All this will be true. Unless you have if true, then false. Okay? The first statement true and the last statement false. It will make the truth or value of the statement false. So please remember again for if then statement. If the first statement is true, then the second statement is false, then the truth value of the whole statement is false. So that means it depends on the true followed by false. If true, then false, then the statement will be false. Alright, so I highlight again. If the first statement is true, then the second statement is false, then the truth value of the statements will be false. Other than this, all will be true. This is special for if-then statement. Okay, for the next one, you are asking to write the contrapositive for the statement and determine the truth value. So you have to follow exactly the pattern here. So if not Q, so you have to negate the Q, then not P. Alright, so you have to follow exactly the contrapositive. If you have to negate the Q, then you negate the P. So the Q comes first. So if 2 times 3 not equal to 15, just now is equal to 15. Now you have to negate, you make it not equal, but just cut the equal sign. Then, okay, you also have to negate the P statement. Okay, so 2 plus 3 is not equal to 5. So that is how you do the contrapositive. And then the statement is, you have to check whether it's true or false. So now we are having the first statement is true and the second statement is false. As I say, if you have first statement is true and then second statement is false, this is the only combination that will give you the false statement. Other than this, all will be true. Again, if the first statement true, second statement false, then the statement if-then will become false. Okay, so please memorize the if-then statement. It is very special. The first statement true, second statement false, okay, then it will be false. That means if P is true, then Q is false, then the statement will be false. Alright, okay, please memorize the way to answer this type of mathematics reasoning. During your exam, you have to memorize the table here. For implication, if P, then Q. For converse, if Q, then P. For inverse, if tier P, then tier Q. Tier P means you negate the P, and tier Q means you negate the Q. For contrapositive, if tier Q, then tier P. So that means for contrapositive, you have to reverse the inverse. If not Q, then not P. So all this is very important. You must memorize it. Okay, let's see this one. P statement, 2 is a prime number. Q statement, 3 is a factor of 9. So combine the two statements above P and Q using and or to form a compound statement. So we just copy 2 is a prime number and we combine with the Q statement, 3 is a factor of 19. Okay, that is how you form the compound statements. For number 2, we have to form another one. 2 is a prime number or 3 is a factor of 19. So we just combine using the word or. Then we copy the statement Q. 3 is a factor of 19. Okay, just combine the two statements using or, that is so-called compound statement. For number 2, hence determine the truth value of each of the compound statement. So we have to label the first statement. 2 is a prime number, so it is true, and 3 is a factor of 19 is false. So because of n, so either one false, it will be false. So the compound statements for 2 is a prime number and 3 is a factor of 19 is false because of the n. Okay, because of the n. Okay, if n true, false, it will be false. Alright? Okay. How about for all statement? 2 is a prime number or 3 is a factor of 19. So we have to analyze the 2 is a prime number is true, and then or 3 is a factor of 19 is false. For all statement, for compound statement using or, either one true, it will be true. Okay, for a compound statement, true or false, it will be true. Okay, so please memorize the concept. Alright, due to or, so either one true. Okay, the compound statement using or will be true. Okay, so this is how you decide whether the statement and or is true or false. Let's study how to do this kind of question. So before we do, we need to understand this. If the conclusion is false, then the argument is weak and not cogent. Okay, the conclusion false, the argument weak and not cogent. Okay, if the conclusion is true, then the argument is, say, strong argument. Okay, it is strong argument. So if the conclusion is true, then we will have to check all the premises. If all the premises are true, then we say the argument is strong and cogent. So if the conclusion is true and we check the premises and one of the premises is false, so we will say the conclusion is strong but not cogent. So for this type of question, so you have to check the conclusion first. If the conclusion is false, then the argument is weak and not cogent. Okay, if the conclusion is true, then the argument is strong. And if it is strong, then we will check all the premises. If all the premises are true, then we say the argument is strong and cogent. If the conclusion is true and we check the premises and one of the premises is false, then we say the argument is strong but not cogent. So for question like this, we will study the conclusion first. Okay, let's study the conclusion for this question. So all factors of 12 are divisible by 3. So let's look at the conclusion. All factors of 12 are divisible by 3. So is the conclusion true or false? Okay, let's analyze the conclusion first. If the conclusion is false, then we will say the argument is weak. Okay? And it also not cogent. If the conclusion is true, then we will check all the premises. If all the premises are true, then we will say it's strong and cogent. If all the premises or one of the premises not true or false, we will say it is strong but not cogent. So let's study the statement first. So let's have a look of the conclusion. Premise 1, premise 2, and premise 3. So we need to analyze carefully before we can decide whether the argument is a weak and not cogent, or a strong and cogent, or a strong and not cogent. So we want to determine whether the above argument is strong or weak. So we have to look at the conclusion. Now let's study the conclusion. All factors of 12 are divisible by 3. So let's list out all the factors of 12. Factor of 12, we have 1, 2, 3, 4, 6, and 12, right? So out of all these factors, are they all divisible by 3? no, 1 and then 2 and 4 are not divisible by 3. So the conclusion is false because not all the factors are divisible by 3. 1, 2, 4 are not divisible by 3. So the conclusion is false. When the conclusion is false, okay, the conclusion is false, so we will say the argument is weak and not cogent. Alright, if the conclusion is false, then the argument is weak and not cogent. So I highlight the important point that you need to memorize using the blue highlighter. If the conclusion is false, then the argument is weak and not cogent. So this is the answer for this question. So to all my dear students, if you follow my video teaching, I would like to say good luck to you and enjoy your study, enjoy your maths. Okay, with that, bye-bye. Have a nice day.